Today's lesson is starting chapter 6, and this is chapter 6, lesson 1, and the topic is similar polygons. And maybe we'll start with polygons are just shapes connected with straight sides. So a square is a polygon, triangle is a polygon. So, learning intentions. Number 1, first learning intention is to understand the definitions of similarity. So what makes polygons similar? The definition of corresponding sides and corresponding angles. The second one is to be able to identify figures as similar. So you have two figures. Can you tell if they're similar? Why or why not? And name them accordingly. So can you give them names that are done correctly? And the last one, to use your knowledge of ratios to calculate the missing side length of similar figures. So given two figures, let's say you're told they're similar, but one of the sides lengths missing, can you use all of that ratio information you used in chapter 1 and 2 to solve the missing side? Let's look at what corresponding sides, angles, and what leads to similarity. So first, two figures are similar. They're similar if they have the same shape but are different sizes. So these have the same basic shape, and they're different sizes. One is bigger than the other. If they were the exact same, they would be called congruent. So I'm just writing that up just in case I don't remember to go over it again later. Congruent would be exact same size. These one's a little bigger than the other, so these are similar. Now what makes them similar, because maybe they're not perfectly similar, but to be perfectly similar, two figures are said to have the same shape, that is be similar, if their corresponding angles are equal. So first, we kind of need to name this. So let's name this A, B, C, D, starting in the left corner. This is shape A, B, C, D. Now to name the next one, if we started in the left corner here, we must start in the left corner here. So R. And then when we did, so I'm just going to make that a little cleaner. When I went A, B, I went to the right. So I must continue in the same order. So top left, top right, bottom left. So R, S, T, U. So I did not name this one. If this one was A, B, C, D, I did not name this one T, S, R, U. It must be in the same order. So top left, top left. So A corresponds to R. So if A is 90 degrees, in order to be similar, corresponding angles are equal. So angle A is 90 would mean angle R would have to be 90 because they're both the top left. If angle B was 120 degrees, then angle S would have to be 120 degrees because the second one has to be the same as the second one if they're similar. So if angle T was 95, angle C is 95. So if the question said, angle D is 70 degrees, how big is angle U? Well, if their question told you they're similar, then the corresponding angles have to be the same. So if D is 70, U would also have to be 70 because D corresponds to U. So first in naming them, make sure they go in the same order. And then the first one corresponds to the first one of the next one. So they are similar if corresponding angles are equal. 90, 90, 120, 120, 70, 70. Now, if the two figures are similar, so these are similar, and I know they're similar because they have the same or equal angles for all their corresponding corners. 90, 90, 120, 120, 70, 70. So, because I know they're similar, it means that their corresponding sides will have the same proportions or ratios. So, corresponding sides. Notice this long one, straight one on the left. We'll call it AD because it goes from A to D. So this is side AD. It will correspond to RU. Okay, left, left. So the corresponding sides will have the same proportions. Let's say this one here is length 20 and this one's length 10. What it means is 20 and 10 means this one is twice as big. Okay, 20 and 10. So if the one's ratio is 20 over 10, okay, AD is 20, RU is 10, then if I told you AB was 8, so let me just write this up. AD was 20, RU was 10. That means the ratio of size difference, if you divide them, is 2. Now if I told you AB was 8, I'm going to say this here is 8, how big is RS? Well, if AB is 8, we know that this one is twice as big as this one. So RS would have to be 4. When you divide them, it equals 2 because they equal the same ratio. So to review everything here, first, they are similar if they're the same shape but different sizes. What makes them similar is if the corresponding angles are equal. And last, if the corresponding sides or angles are equal, then, and you're told it's similar, or you've measured them all and you found them to be similar, then you know that the ratios will all follow a certain proportion. This one's 20, this one's 10, it means this one's twice as big. So if this one's 8, this one's 4. If this one's 12, this one would be 6, because this one is twice as big as the other. And we'll take a look at more of those. Here's another example. The two shapes are similar. So I've drawn them up roughly. I guess if you measured them, they're not. But let's say the question tells you they're similar. Number 1, name shape 2. So if this is shape 1 here, and I've named shape 1, I've named shape 1 EFGH, then what is the name of this one? The key is to name them, not necessarily in alphabetical order, but to name them correspondingly. So E was the top left. So this shape will be called X. And then it went EFGH, so EFGH. So I need to follow that down. So X, Y, Z, A. Okay. So I've named them, so E corresponds to X, F corresponds to Y, G, Z, so on and so on. So now, find the missing lengths. And the missing lengths are all of the green question marks. So for this question, what I have is, I need first one side from each to determine how much bigger one is than the other. So I have this side and this side for both of them, okay? 21 and 7. So I'm going to take the bigger one, divide by the smaller one. The one on the right is 3 times bigger. So I can take these numbers here, and I know these ones will be 3 times bigger. So notice I wanted to find this. Well, its corresponding side is 11. This one is 3 times bigger. 11 times 3 is 33. Now, obviously, these aren't drawn perfectly because 33 and 21 looks longer. So when a question says it's not drawn to scale, don't worry if it doesn't look correct. In general, they'll be close, so it's a good hint. But if they tell you they're similar, trust the book that they're similar. Now, remember, this one is 3 times bigger. So 1 to this one, 1 times 3 is 3. So this length here is 3. And now the last one we don't know is, we actually don't know anything about these two. So the question didn't even need those. But we have 9, and then we don't know this one. So remember, this one's 3 times bigger. So this times 3, or think of it, this one's 3 times smaller. So we divide by 3. 9 divided by 3 is 3. Okay, and then we'll look at one more example. Given two similar shapes, so we've got two similar triangles, and it says they're similar, so they are. And similar means all of their angles, corresponding angles, will be equal, and the corresponding sides will all contain a certain ratio. So first, let's name them. Let's name this one this way. So this is A, B, C, A, B, C. Then this one is F, G, H. Now, A corresponds to F, B corresponds to G, C corresponds to H. So when the question up here says find the measure of angle G, G corresponds to B. So B and G are going to be the same. So if we want to find G, all we need to know is if B is 60, Okay, B is 60. Then G is 60. And next, find the length of FG. So, with the previous questions, it was always like twice as big or 3 times as big. It was easy to see. Let's say these aren't as easy. 12 and 5, let's see how that relates. So, one way to do this would be to find the ratio, and you could do 12 divided by 5 equals 2.4. So we know this one's 2.4 times bigger. And some of you will intuitively know what you're going to do with the math there, times or divide. You'll do it correctly. But for the rest of you, if you don't, what you can do is you can set up a ratio. The ratio of this one, so let's say I'll do the large one over the small one. So if the large is 12 and the small one is 5, okay, corresponding. Now if the large one up here is 15, the small one is x. And now you can cross multiply, you can use your fish technique, whichever method you want. And so this one, 15 times 5 is going to give me 75. And then when I take 75, so again, fish technique, 15 times 5 divide 12. 15 times 5, again is 75, divide 12 equals 6.25. So this length is, so length FG is 6.25. So these questions won't always necessarily work with nice perfect answers. Sometimes you get decimals and fractions. Don't be afraid of them. They're numbers too. Okay. So that looks like everything we need to cover for this section. You can work through Chapter 6, Lesson 1 in your workbook. When you get on to Chapter 6, Lesson 2, go and watch the next video. Good luck. Stay classy, math class.